This problem, unfortunately, is going to take a lot of work. Let's start with the idea that, first off, we're told at this point we're looking for some point of tangency to the blue curve here. That blue curve is 6x squared, and we're told the x value there is x equals 2. In order to get the corresponding y value, I'm going to take 2, plug it into this function. 2 squared is 4, times 6 is 24. So now that I have that point, I have a point of tangency with which I can then make a tangent line once I get the slope of that tangent line. Why am I doing this? Why do I have to go about trying to figure this out? Well, here's why. I want the area of this shaded region, and unfortunately, the shaded region is not quite the same everywhere. That is to say, here, everywhere to the left of this pink line, the area above, or the area is bounded by this blue curve and the x-axis. On this side of the pink line, the area is bounded above by the curve x, 6x squared, and then bounded below by the line, not by the x-axis. So I have to split this into two separate integrals. One where I integrate from 0, because the left bound seems to be 0, up to this pink line, wherever that pink line may be. And I'm just doing 6x squared dx here because that's the function on top. The function on bottom is the x-axis, so that's 0. Then I have to add the integral from, again, this unknown pink value up to x equals 2. 6x squared is the function on top minus some unknown green mystery function that I don't know yet. So I'm going to go ahead and figure out what that green mystery function is for starters. How do I do that? Using Calc 1. So in order to make the equation of a line, you need a point, which we have, and a slope. The slope we get from the derivative. The derivative of 6x squared is 12x, and when I plug in x equals 2, I find the slope at x equals 2 is just so happens to be 24. So I get, this should be a 2, 24. So that tells me the slope, that tells me the point. I'll just make a line. We have y minus 24 equals slope, which is 24, times x minus 2. I'm going to distribute the 24, and I get, let's simplify this a little bit. I get y equals 24x plus, nope, not plus, it's going to end up being minus 24. So I have y equals 24x minus 24. This, by the way, is this magical green curve here. And so you know what? I'm going to go ahead and put it right here, 24x minus 24 dx. The last thing I need are these missing bounds. And the way I do that is figuring out where this line y equals 24x minus 24 intersects the x-axis. That is to say, when is 24x minus 24 equal to 0? If we do some quick solving here, though, we end up finding that x equals 1. So the magical value of x that gives us this pink line is x equals 1. Okay, now that we've done that, it's time to integrate. When I integrate 6x squared, I get 2x cubed. Plug in 1, plug in 0, find the difference, and that just gives me 2. Easy enough. When I integrate this guy, it's going to take a little bit of work, but I'm going to get 2x cubed minus 12x squared. Minus minus makes plus 24x, and I'm evaluating this from 1 to 2. When I plug in 2, I get 2 cubed is 8 times 2 is 16. 2 squared is 4 times 12 is 48, so minus 48. 2 times 24 is 48, so I get plus 48. Minus what I get when I plug in 1. 2 minus 12 is negative 10, plus 24 is positive 14. So I'm going to end up getting, these cancel, 16 minus 14 is 2, plus the 2 from a 4 gives me a final answer of 4.